Okay, year 13 calculus. Here I'm going to give you some more examples of how to work out definite integrals. This first one is about finding the value of the integration of a trig function from a point of view of a definite integral. So here we're being asked to integrate cos theta d theta between 0 and pi. Okay, now of course, this cos theta is the derivative of what function? It is sine theta. So when we integrate this, we write sine theta, but we must draw this line and put down the limits 0 and pi. Now, to figure out our answer, we substitute in these limits. The first one we substitute in is the pi for the theta, and then we put in 0 for the theta, and that's what I've done down here. So we're going to be putting in sine theta, and then that all-important minus sign here, minus sine of 0. Okay, that's the 0 there instead of the theta there. Well, you should know from the basic graph of sine that the sine of 0 degrees or 0 radians is 0. But the sine of pi radians is also 0. Now I could explain that using the unit circle and show you why the sine of pi, or 180 degrees, is 0, or you could try that on your calculator and see that you do get 0. So it's 0 taking away 0, and that is nothing. Now, and that's the answer. Now, you may say to me, well, hang on, sir, you've been telling us that when we do an integration like this, we're finding the area underneath a curve. Well, how do we get 0 for an area underneath a curve? Well, what I've gone and done here is I've tried to show you why this happens in this particular case. The reason is because the cosine curve is something like this, between theta equals 0 and theta equals pi. And it crosses there the theta axis at pi over 2, okay, or 90 degrees, and that's 180 degrees. But the important thing is it is symmetrical about the theta axis. This means, of course, that this area here and this area underneath the axis are both the same. Now, what happens is that when we're doing the calculus, when we're doing this thing here, when we're finding the area between 0 and pi, between 0 there and pi there, we're finding this positive area and we're finding this negative area. And of course, when you add them together, they cancel each other out. They become 0. For example, if this was an area of positive 2, this would have an area of negative 2. And add them up, you get nothing. So that's why in this particular case, doing this, you're integrating between 0 and pi for cosine, you're going to get 0 as your answer for the area. All right, now this next example is was the one you tried in while we were online. I asked you to find the value for the integral between 0 and pi over 2 of 5 sine 3 theta d theta. So what you should have been doing is the following. You first of all realize that you've got to replace this 3 theta with u. So you're changing the variable. So we say let u equals 3 theta. So du by d theta is 3, so du is 3 d theta. So in other words, if we pre-multiply this d theta here, there, by 3, we've got to divide by 3 at the same time to keep the integral the same. Well, that now can be put in front of the integral sign, and as well as that, this 5 can go in front of the integral sign as well. Okay, there it is. Now, what are we left with? Well, we're left with the integral of sine. Instead of writing 3 theta, we can write u. There it is, sine u. And instead of writing 3 d theta, we can write du. But look what we've done. We've changed the variable of the integration to u. It's now no longer theta, it's u. But these limits here, these limits of 0 and pi over 2, they refer only to theta. So that's why when you change the variable into u like this, you can't write 0 and pi over 2 here because they only refer to theta. So it's much easier to write just u1 and u2. You can actually find the values of u1 and u2 because you know how they're connected here. And I've done that there. I didn't have to do this, but it makes it quite understandable as to where these limits would come from. For example, here u1 is also 0 because when theta is 0, 3 times 0 is 0, so that's going to be 0 as well. But when theta is pi over 2, then it's 3 times pi over 2 for u2. There. Okay? But we don't really need to go into that because when we go back to the original theta variable, we can just use the original limits of pi over 2 and 0. So here is the next step. So we now integrate sine u. Well, this is positive sine u, and when we differentiate cosine u, we get negative sine. But we are integrating positive sine. So when we go back to the original function must be minus the cosine of u. Okay? So we've got this 5/3 multiplying this minus cos u. Now, if we put it back into theta form, you can see we've got the following. We've got that the 5/3, and I put these squiggly brackets in so as I can write my limits outside them. But now we're going to substitute in the limits of pi over 2 into the 3 theta here. Okay, so my first one in is there. So it's going to be minus cos 3 times pi over 2. So this is really, all of that's an angle. It's 3 pi over 2. Minus that all-important minus sign. Now when we substitute in the variable 0 for theta there, and there it is, 3 times 0. Now we have to be a bit careful with our signs, but it's okay. If you work out what the cosine of 3 pi over 2 is, or 1.5 pi, you find that it comes to 0. So all of that brackets reduces to 0. This one, however, this is really the cosine of 0 because 3 times 0 is 0. The cosine of 0 is actually 1 plus 1. But the plus 1 is being multiplied there by minus 1. You can see that minus is there. So all of this goes to minus 1. But minus 1 has got this minus sign here outside. So all of that's going to go to plus 1. And that plus 1 multiplies the 5/3 to give us 5/3 units squared. So that is the answer for that particular question there. All right, now let's go on to the next one. I think I've got just enough time to do it. And it is here. Yeah, I'm showing you now how to integrate exponential functions that are indefinite, that are inside, a definite integral. So here we have a definite integral. We want you to integrate between 0 and 4 the exponential function e to the power of 2x dx. Well, again, we say let u equal 2x. So this means that du is 2 dx. So we pre-multiply this dx with 2, divide by 2 at the same time, take this outside the integral sign. There it is. So it's a half multiplying the integral of EU du. Okay? Because the 2x is the u, the 2 dx is the du. But again, look what we've done, or what I've done. I've taken away the 0 and 4 limits, which refer only to the x variable, and I've just written u1 and u2. Okay? Because the variable is now in u. Well, when I integrate EU, I get EU. Okay? So that EU is really e to the power of 2x, but it's multiplied by a half. Don't forget, draw that line and put down the limits. Now I'm going to put in the limits of 4 for x and 0 for x. So here it is. So this is a half e to the power of 2. Now that must go to 4. So that's going to go to 8, as you can see there. And this 2 to the power 2 times 0 is going to give me 0. E to the power of 0 is 1. So that's 1 times a half is just a half. So when you work that out on your calculator, you could either leave the answer like that in terms of E, which is the sort of grown-up way of doing it, but sometimes they ask you for a numerical answer, and if you put this all in your calculator, you will get the answer 1490. Okay, now here's a one for you to do, or one of the ones I asked you to do. And I'll go through this very quickly because I'm running out of time. And we're going to be integrating between 0 and 6, 5 e to the power of minus 3x. Well, again, you let u equal minus 3x, what's in the exponent here, and you differentiate so you can write that du is minus 3 dx. So we pre-multiply the dx here by minus 3, divide by minus 3 at the same time, take that outside the integral sign, take this 5 also outside, so as to make the integration as easy looking as possible. So we got this thing here, 5 over minus 3, and you're integrating with respect to u now, EU du, so these variables have to be changed, these limits have to be changed to u1 and u2. Integrate that, get EU, and the u is minus 3x, so we put that back like this. And now we work this out. We put in the limits of 6 for the x, so there it is there. So it's e to the minus 3 times 6, which is going to give us minus 18, minus, when we put in the 0 for the x there, as it is there, that's going to go to 0. So anything to the power of 0 is 1. So there's a minus 1 there. So if you work that out in your calculator, you will get 1 and 1/6 recurring, or as I would prefer to have it, 1 2/3, like that. Okay, now I'm going to show you in another video a trig product definite integral, which is quite tricky. So I'm going to need the full allotted time to explain that. Okay, thank you very much.